Hello, in this lesson, I wish to give you some guide on the homework. The last questions, the last two questions, number 4 and number 5. Number 4, you encounter some roots questions, right? So I'd like to just briefly review that the relationship between roots, root expression and the power expression, right? Recall that in the homework guide, we reviewed the power, right? Recall the power rules. The power rules include cases like b to the power m. Okay, so if you haven't watched this and you think you need to watch this, please watch the video last week because we have derived these properties. We have derived these properties. And I really wish you guys to derive these by yourself instead of rely on memorization, which can be very frustrating. Okay, I personally don't want to have to memorize a bunch of formula. That's why I show you guys to how to derive them. Okay, so this is b raised to the power of m minus n. So there are a bunch of other properties here. And the other ones, such as a times b to the power of n equals to a to the power of n and b raised to the power of n. And division-wise, we have a divided by b to the power of n equals to a to the power of n and b to the power of over b to the power of n. And of course, provided that that base cannot be 0, right? We cannot allow 0 denominator. And the next part is other properties such as b raised to the power 0 is equals to 1, but provided b cannot be 0. This condition is absolutely important. Okay, and b to the power of negative n, okay, is equals to 1 over b raised to the power of n. Okay, I think there's another property, which is b raised to the power of m, and then raised to the power of n equals to b to the power of m times n. Okay, be sure you know how to derive them instead of going through the memorization process, which can be very frustrating. Okay, but anyway, without further ado, that these are the properties about power. These are the properties about power. And I think these can fit in one line. Okay, which will be nice, right? We can actually, you don't see the negative sign here. So let me just go back to the previous fonts, okay? To make sure you can see it. So we make it 2 line. That's 2 line, that's fine. Okay. So you can see that it's easy to recognize that mn are integers, 1, 2, 3, 4, 5, 6. Those are pretty easy to operate. But I wish you to understand that these numbers can actually be fractions. These numbers can be fractions. Okay. For example, we can totally have b raised to the power of half multiply b raised to the power of third, and that will equals to b raised to the power of half plus third. Okay, and then we will operate the power. We'll operate the power to find common denominator, which is 3 over 6 plus 2 over 6. So in the end, we get b raised to the power of 5 over 6, right? So you can see there's a lot of convenience when we operate the powers in this situation. But the question is, well, when we have fraction as our power, what do they mean? In fact, b raised to the power half is square root of b. The base b, okay, stays inside the root. The fraction, okay, which have a denominator 2, the denominator goes here, and the power goes with the b. Okay, and of course, the default notation for square root with root 2 is, we don't have to write the 2. B to the power 1 is b. Okay, and similarly, b raised to the power of 1/3. Okay, b to the power 1/3. Okay, is similar, right? And the 3 will go through the root part, and b to the power of 1. So in this case, it's cubic root of b. You can see this operation, if we use the power operation, the root operation can be, can be carried out this way. Okay. Now, so you can see there's a transformation between fraction power to exponential form, In general, okay, if we have b raised to the power of m over n, okay, it's a fraction form, and that will be, the denominator will go to the nth root, and this part will be b to the power of m. All right, so the root can be written as exponential form and vice versa. So with that said and done, that once you transform a root form into exponential form, these will be much easier to calculate. But we do have another very important consideration, is that when we need to consider domain. Okay, domain oftentimes is an important issue. Okay, is an important issue. Okay, is an important issue in these operations. Okay, for example, we often have these, some student will say, hey, x squared, right? This is square root. Some people will do this. They say, oh, there's a root 2 there. Right? So this is x squared, right? They will cross out the 2 and give it equals to x. And we know this is wrong. We've talked about it. We talked about it in previous videos many times, right? This operation, why it is wrong? If you have learned it this way from your previous teachers, your previous teacher might have mentioned a specific condition, okay? So this is wrong, okay? But could this be right sometime? Yes. It would be right if your previous teacher mentioned that this has to be, x has to be greater than or equal to 0. You see, this will be right and that would be wrong. Okay, so only in this case you can do the cross, you can do the crossing. Okay. All right. And so this is very important to be aware of the domain. And the other factor I like to mention is that depending on the root is even number or odd number, it makes a big difference. For odd number roots, usually there's no problem. Okay, for example, if we have cubic root, then you may wonder why we have to heap to this situation, right? In this situation, yes, it just equals to x, right? No problem. There's no issues. There's no problems. But why there's a problem if we have odd number? There's no problem for odd number roots. Why we have problem with even number roots? It's all because of domain. It's all because of domain, okay? It's a domain issue, okay? So this is right. All right. All right. So what is wrong here? Why this is wrong, right? Why this is wrong? Why? Why this is wrong? Right? Why this is wrong? Because of domain issues. Okay. The domain for this function, right? Suppose this is a rule, right? This is certainly a rule for this function. It's all real numbers. X is all real numbers. X can be all real numbers. No problem. Okay. If it's all real numbers, then X can be negative, X can be positive. So we know this is right? If X is all real numbers, it could be that if X is greater than or equals to 0, right? So in this case, yes, absolutely, this is true. This is always true, right? But what if X is negative? X is negative, right? When X is negative, we know that this is equals to what? The absolute value of X. Absolute value of X. And the absolute value of X of a negative number is its opposite. Is its opposite. Okay, that's why. That's why. There's another important result that we often use, right? We have touch base with both functions. Is that we know that absolute value of, right, for any real number, for any real number X, right? We know this is true. We talk about this in the previous videos, and we know this is true. Okay. And there's another question. There's another question, which is this one, right? Root X parentheses squared. This equals to X. Okay. What's the difference? Do they have any contradiction? Do we have any contradiction? Do we have any contradiction? This is oftentimes another important questions, and the student really confused. When I was a student, I was also confused. Okay, so first of all, you have to see that the domain for square root of X squared is all real numbers. In this situation, right? The domain issue for root X, right? This is very much related to the order of operation. In the order of operation, you have to do square root of X, and then we square, right? So when we process square root of X, we have to understand the domain of that is greater than equal to 0. We have done the discussion in the first week, right? So by writing it this way, it has automatically guaranteed that the x is going to be in the domain of this rule of function. Therefore, x is greater than equal to 0. So as a result, and this is going to be equals to 1, equals to x itself, because x is going to be, it is implied, right? Because every rule function, has a domain that comes with it. So in this case, it is equals to x. And in this case, it's absolute value of x because the domains are different. I hope this will clarify for us. Okay, very important. We often encounter these issues. Right? So in this situation, the domain is implied because every rule we have to operate within the domain of that specific rule requires. Okay, so these two have a different domain. This domain is all real numbers, and this domain x be greater than or equal to 0. Okay. Next. Okay, next I wish to go over number 5. Okay, number 5. Okay. Last week we did rationalizing the denominator. So this week we're ready to do rationalizing the numerator. And these questions are actually more practical for your future calculus classes. Okay. In fact, most of these questions I have here are taken from your calculus text. They are taken from your calculus text. So I'm going to do a couple of examples here to demonstrate to you how these need to be operated. In your calculus class, the question will not be asking you to, rationalizing the numerator. Okay, it's going to be in a different setting, right? Asking you to find limit or something else or something. But you find yourself, you cannot apply those rules of calculus. So you have to go about to modify the form of the function. Okay, so let's look at the first one. The first one. How do we go about it? Right? In order to solve your calculus question, you need to use this little algebraic skill, which is to rationalizing the numerator. Okay. And how do you rationalize a numerator? You're going to find the conjugate of the top because we have radicals in the numerator. Okay. The conjugate in the top is the square root of 4 plus h plus 2. And we're going to multiply by 1. We're going to multiply by 1. All right. And now denominator times denominator. So we have h multiply the denominator. Okay. And the numerator is in the form. The numerator is in the form of a minus b times a plus b. Right? We talk about that. Conjugates, the product of a conjugates. Okay. At the beginning of your calculus class, very soon you're going to encounter these questions. Okay, so this basic skills, right? You definitely need. You definitively need it. All right, so our a is 4 plus h in square root. That's our a, right? That's our a. So that's your a. That's your a. And that's your a. There, right? Your b is 2. So 2 squared. You can see the numerator will turn into something like that. Okay, a minus b times a plus b. That's how. Put this on scratch paper. You don't need to show me if I ever ask you to do it. Okay, so your work, just show this part. Just show this part. I would recommend do not multiply this. Do not do distribution in the denominator. Don't do it. Don't do it. Don't do it for me, and don't do it for your calculus class. You will like this form better. Like, trust me. So now 4 plus h inside the root and then squared. Remember, we just talked about, right? The square root of x. The square is outside, and that equals to x, right? We just did that, right? So here our x is 4 plus h. It's 4 plus h. So assumed it's in the denominator. So that's what we're using. So here on the top, you're gonna get 4 plus h minus 4. Okay. And the next step, of course, you're getting 4 minus 4, and there's only left with h. And you can see now you understand why I told you do not multiply, right? Do not expand in the denominator. H and h will be reduced. So in the end, okay, we got 1 over 4 plus h in the square root plus 2. Okay, so once you're in your calculus class, you understand that when you get some form like that, even though these two are the same from the way we operate, but for this expression, you can apply the rule of your calculus definition or whatever, your limit property, and to proceed with your steps. Okay, we have 12 questions in this section, and I really did not create any one of these questions. They're all from your calculus text. So practice on these and be able to do these correctly really give you a good exposure and give you an upper hand on your calculus classes. So let's look at number 3. Let's look at number 3. Number 3, we have root of x squared plus x minus x. Then you say, oh, where's the numerator? Of course, there is a numerator, right? This form, you can view this as there's a numerator and there's a denominator 1, right? So to rationalizing the numerator, you're going to multiply the conjugate of the numerator. The conjugate of the numerator is the square root plus x. Okay, the square root plus x. Anything times 1 stay the same. Okay, so once again, we're going to use that property, right? A minus b, a minus b times a plus b, right? A plus b equals to a squared minus b squared. All right. So when we apply these conjugates, right, our a is the square root, this one, and this one. See, and b is x. B is x. Right? So now you see very clearly, and denominator is 1 times that, so it stays the same, doesn't change. So what's in the numerator? What's in the numerator? And this is going to be in the numerator. Okay, this is going to be the numerator. Pretend that these are on your scratch paper. Okay, what I put in the bracket is on your scratch paper. When you show your work, you just have to show these. Okay, when you show your work, you just have to show that. And next, right, we have denominators stay the same. And what's on the numerator? What's on the numerator? A numerator, we get to use that one more time, right? We got to use that one more time, right? This guy, right? We got to use this guy one more time. You see, this is pretty useful stuff, isn't it? There. So we can use that property. Okay, that property is going to give us x squared plus x minus x squared. Minus x squared. Okay. And then you can see x squared and x subtracting x squared. So that's going to make, that will make 0. And so in the end, we just have x over. So it is rationalized. It is rationalized. Even though in your calculus class, you still have to do one more step or maybe 2 more steps to make, to make things happen, Okay. So we've done a couple of examples. I think I would like you guys try the rest. Okay, try the rest. And if you have any questions, please let me know and I'll be happy to help. Okay, thank you for watching. Until next time. Bye.